Okay, so in this video lecture we'll be going to talk about the different representations of organic compound as dash formula, condensed formula, or bond line notation. So we just saw one of the examples in the previous lecture in which I discussed a simple long chain carbon compound with hydrogen atom substituted on the carbon atoms, and we looked at it at dash formula and condensed and bond line. So in this video lecture will be going on to cover some other examples of different organic compounds so that you can get a complete feel on the representation of these compounds. So okay, so let me start off with the example here. So let's say we have a unsaturated bond or a double bond in a hydrogen in a organic compound. So how do you represent it as the dash formula? So this is simple notation in which I have given okay, this is a double bond, and we need to show how it can be represented as the condensed formula and a bond line notation. So just by filling the remaining valencies of the carbon atoms, like in this for this carbon atom, two valencies, this and this are already been filled by the other carbon atom, the second carbon atom. So only two valencies are left for this carbon atom, so which will be filled in by the hydrogen atoms. So we need only two hydrogen atoms for the first carbon atom, and the same thing I can say for the second carbon atom, right? So how do I write the condensed formula for this dash formula, right? So as I said, the condensed formula is nothing but we just compress the bond lengths of carbon and hydrogen atoms, and we just show the connection between the carbon and carbon atoms with the single bond. Okay, so for this carbon atom I can say that okay, the bond length reduction for this carbon atom would result into a CH2. Now I need to take care for this double bond, so it would be double bond, and the same I can say for this CH2 as well. So this CH2 is also CH2. So this is the condensed formula for representing alkene. This is commonly known as alkene. We'll be looking into the IUPAC names in the upcoming lectures, but for now you can safely you can say that okay, it's alkene. You can just say that we'll be delving into how do we actually derive it, what are the common names, what are the IUPAC names in the next lectures. So what would the bond length notation for this compound? Bond length notation would be nothing but, as I said, that the number of carbon atoms are the number of vertices in the bond length notation. So how many number of vertices would be there in the bond length notation? Exactly 2, because we are only talking about 2 carbon atoms here. And now as we said that we'll be representing the number of the bond lengths directly between 2 carbon atoms in the bond line notation as well, so it would be simply a bond, right? So this is just for the understanding sake. We can actually write it as this also, right? This also means the same thing. When we are not showing the vertices, the endpoints are automatically treated as the vertices. This is general convention which is followed all across organic chemistry, right? So now let's look at the next example in which we'll be dealing off with some of the cyclic compounds, like let's suppose I give you this cyclic compound. So from this I need to know the condensed formula and the bond and the dash formula for this cyclic compound. So what would be the same for the cyclic compound? The condensed formula would be nothing but as you can see, there are 3 vertices in the bond length notation. So the condensed formula would be just C, as we should show the bond length between the carbon atoms, and we'll be later on compressing the bond lengths between between the carbon atom and the hydrogen atom. So how many hydrogen atoms would be there? As 2 valencies are already been satisfied for this carbon atoms, only 2 valencies are left for the hydrogen atom, so it would be CH2. Similarly I can say for CH2 here and CH2 here. What would be the dash formula for this carbon compound? The dash formula would be nothing but just expansion of all the hydrogen atoms attached to the carbon atom. So expansion of all the hydrogen atoms bond length with the carbon atom would be C, again C, and again C, and we are just connecting the carbon atoms together. Okay. So let me delve into the third example. uh, so let's suppose we have triple bond in triple bonded carbon atoms. So by triple bonded I mean double unsaturation. So triple bond C attached to each other and only one valency is left to satisfy the carbon atom. So we'll be directly attaching it with H. Similarly, I can say for this carbon atom, what would be the condensed formula? Condensed formula would be nothing but just condensing the number of hydrogen atoms attached to the carbon atom and just showing all the bond lengths between the carbon atoms. So this would be the condensed formula. What would the bond line notation? Bond line notation would be nothing but just triple bond. As I mentioned earlier, it is directly understood that if I just write this, it is understood that the endpoints are the vertices or the carbon atoms attached. Okay. Now let us look into the example wherein we need to substitute some atoms which are different than hydrogen atoms but are connected to the carbon atoms. Just like for example, oxygen is attached to the carbon atom instead of hydrogen atoms. So what happens when we have to write the bond length or the what happens when we have to write the bond dash formula and condense and bond line notation for those type of organic compounds? Okay, so let's take an example for the same. If we have some dash formula like this, then I'm just attaching a different atom than a hydrogen atom. So I'm in this case I'm attaching this as my uh, uh, atom or the oxygen atom which is directly connected to the carbon atom instead of a hydrogen atom. And just to satisfy the valencies of the oxygen atom, I am just attaching a hydrogen. Okay, so because as the valency of oxygen has to be satisfied by 2, so one is satisfied with carbon and the other is satisfied by the hydrogen atom, right? So what would be the condensed formula for the same? Condensed formula would be nothing but we just compress the number of hydrogen atoms attached to the carbon atom. As for this case, we'll be doing as CH2. Just a second. So let us continue with our example in this case. So what would be the condensed formula for this compound? The condensed formula would be nothing but just compressing the number of hydrogen atoms attached to the carbon atom. Same for the second carbon and same for the third carbon. So in this case we should attach OH directly to the carbon atoms. We won't be compressing the OH as there is no scope for compression here. And what would be the bond line notation? Bond line notation would be nothing but the number of vertices of carbon atoms. Here the number of vertices for the carbon atoms here would be 3. So 1, 2, 3, and for the third carbon OH is directly attached to it. Okay, so we'll look into the one more example in this category. So let's suppose double bonded oxygen atoms are attached directly to the carbon atom. As in this case, we have the expanded bond length or the dash formula for the following carbon compound as this. So what would be the condensed formula? Condensed formula would be nothing but just compressing the number of hydrogen atoms directly attached to the carbon atom. So this would be C. So if we compress this hydrogen atom attached directly to the carbon atom would be CH, and then remaining atoms for directly attached to the carbon atoms are oxygen. So we'll be directly making O here, right? And what with the bond line notation for the same? There are two number of carbon atoms here, so 1 and 2 directly. Oh, sorry. Let me use the eraser. Yeah. So directly attached to this and double bond O. Okay. So this brings us to the end of this video lecture. In the next video lecture, we'll be dealing with calculating the number of sigma bonds and pi bonds in the given organic compound, and we'll be looking at different examples for the same. So I hope you enjoyed the video, and let's meet in the next video. Okay.